Yeah, thank you. Yeah. Sorry, I'm going to start coughing while I'm talking. So, I apologize in advance. Okay, so hi everyone. I'm Ujjwal Panda. I'm a PhD student at NCRA. And finally, after a long time, I'm going to give a talk about this work I did and published this year on a multi-frequency study of the hyperactive repeater FRB 2024-0114A. So you have heard a lot about this FRB yesterday, and so I won't go to detail into what the FRB is about, but I'll give a very short summary. So this FRB was reported as a repeating FRB by the CHIME collaboration on 26 January 2024. Its hyperactive nature was speculated even in their discovery 18, which is the astronomer's telegram, and it was subsequently confirmed by Parks, Muriang, and by FAST when they observed, burst storms and a large number of bursts per hour. And then it was subsequently localized by Meerkat and associated with this particular galaxy. It's a bit of a handful, which was a galaxy that was already detected and characterized in the SDSS survey. At the time, because SDSS did not have any spectroscopic redshifts, we only had a photometric redshift of 0.42. Then the localization was confirmed to within 200 milliarc seconds by EVN Precise, which, as you must have heard, France gave talks about this last week. And then we have the host, again, the host galaxy redshift was 0.42, but the spectroscopic redshift turned out to be 0.13, which again highlights the fact that you can't often rely on photometric redshifts. And this was obtained by Mohit and others. And then this corresponds to luminosity distance of 630 megaparsecs. Associated gamma ray radiation was reported and then refuted in a series of ATLs. And there were observations in X-rays, but there was no X-ray emission reported as well from those. And a PRS was successfully associated by Meerkat, by UGMRT, and by the VLBA. And so, sorry, these are our observations that we did. As soon as the detection was announced, we started doing observations on 25th February. And so these two epochs, we had both phased array and coherently dispersed phased array data. So the phased array data was mostly recorded to actually do the search for the bursts, and the coherently dispersed phased array data was a lower number of channels but higher resolution data that we were eventually going to use to characterize the burst further, get microstructure and things like that. And so we did that in band 4, and then on 14th March, we did a sub-array observation simultaneously in band 3 and band 4. And then after that, we followed up again in July with band 4 with only PA data as well. And so we had a total on-source time of about 18 to 19 hours, and we detected a total of 167 bursts, and with an average burst rate of 10 bursts per hour. So this is a sample plot. Do ignore the submitted, it's already published in AppJ. I forgot to update the slide. But these plots are all available still in my Google Drive. There is also an additional GitHub link, which you can find in the paper, where you have a CSV file with all the burst parameters that you can use. And so you can see, a lot of scattering, a lot of multi-component bursts. This burst, for example, has like 8 components. And you can see, multiple sub-bursts, at trombones, things like that. And so this is the Google Drive where all the plots are available. Feel free to ask for the data and it will be provided upon request. So as part of my analysis, I developed a small package called Scarab with the intention that eventually the analysis package I'm developing will be used for Spotlight. Again, we have talked about Spotlight a lot this week and last week as well. And so the idea is that it will pre-process the data. We mitigate RFI using IQRM. We then carry out a DM optimization based on a package called Shrine, which is something that the Craft team developed for their FRBs. And then the way we fit can account for scattering and multiple components. It's mostly a profile and a spectrum fit. Those are fit independently. And then we determine, we have a small naive-ish algorithm that can determine the band occupancy of the burst automatically, which you can see here. So it has determined that the burst is only in this part of the band and not in the rest. And then we can only pick the spectrum and the profile for only the part where the burst actually is present in the band. And so we obtain an arrival time, intrinsic width, scattering time scale, and so on for each burst. And so these are the burst statistics that we obtained. We had a large sample of bursts, 167 of them. And so we could see that for our 14th March observations, where we had simultaneous subarrays and we were looking at both band 3 and band 4 simultaneously, there is a wider variation in the structure optimized DM, in the intrinsic width, and in the scattering time scale. We could also see that as we did more and more observations, the flux of the burst started to decline. Now, this flux is obtained using essentially a version of the radiometer equation, where we essentially mimic how the GMRT exposure time calculator operates. And so those flux values, we could see that could show a steady decline, ultimately resulting in a much smaller number of bursts and lower flux in our July observations. And then, of course, we did the waiting time distribution. Again, Chahat's talk, you must have heard the same things. But we could see a very clear gap, which at around 1 second, which have not been seen by others. This could be just because of a lack of bursts. Maybe if we had detected more bursts, this gap could be filled up. But we had two distinct distributions in our waiting time. And so because we could see a clear bimodality, we fit them separately instead of fitting them together, because it makes no sense. And so what we did was we fit the the distribution of smaller waiting times with a Weibull distribution, which gave us the best fit. And we fit the larger waiting time distribution with a log normal, because that gave us the best fit. And both of them say that there is some clustering, there's some memory in the mechanism. It's not purely Poissonian. And so, yeah, there's some memory in the emission that is implied by both. Of course, for the waiting time distribution with the smaller waiting times, there is always this issue that we are treating subcomponents as subbursts, and there is no clear way to distinguish between a subcomponent and a subburst, so that it should be taken with like a pinch of salt here. And so then we came to our energy distribution. We first did a completeness analysis following the methodology in Keen and Petrov. And then we got a sample of 91 bursts out of our 167 bursts, which were complete, fluence complete. And then we fit a log normal energy distribution to that, because that gave us the best fit. And that shows that at higher energies, we see a flattening despite having a complete sample. So yeah. So then we did a comparison of our waiting time and energy distributions and our burst parameters with other fits done for other hyperactive repeaters. So we have the usual suspects. We have 121102, we have 180916, 201124. All of these FRBs have been talked about this week. And so we saw that a lot of our values of the K parameter shape, the shape parameter for our Weibull distribution, and our log normal sigma values matched. A lot of these fits were done, a lot of these waiting time distributions had bimodality, and so they rejected the smaller waiting time distribution with the same caveat that subcomponents and subbursts, they can't distinguish between them. And so that's why our sigma values should match with theirs, because we have done the same thing. Okay, so this is my last slide. I'm finishing a bit early. So basically, we continued a campaign on this FRB throughout this year. Once after our July observations, we started our campaign in GTAC cycle 47 in October 2024. And since then, we have detected 126 more bursts from this FRB, making our total now to be about 293 bursts from this source. As you can see a clear evolution. So this is up to our July observation. So these are the bursts that I've talked about in this talk. After that, we see a clear reduction in the burst rate from our October observations, indicating that the emission from the source was probably dying down. And then we see a slow rise in the burst rate. The interesting part is that at first we saw burst only in band 5, which reflects the fact, I think Ajay talked about that in his talk, that the emission was moving to higher frequencies. But then suddenly we saw that the band 4, we started seeing bursts in band 4, which is 550 to 750 megahertz. So that means the emission again began to move to lower frequencies, so that because of which we started to get detections again. And then suddenly there is a shutdown around February and March, which we are going to reconfirm. And then again, the burst switched on again in both bands 4 and band 5. And then suddenly showed a flip where band 4 gave us more detections than band 5, showing that the shift was even more drastic. And then band 5 stopped giving us detections at the very end, and we only have detections from band 4, which shows us that, the emission is probably moving around in frequency. It's not just a steady trend towards higher frequencies. And so this, the entire campaign was spread across 2 GTAC cycles, which gives us about 12 months of data. And so, yeah, this will be published soon. So keep an eye out for my future paper. Thank you.
Oh, Ujjwal.
I'll leave with the summary slide. Yeah.
Yeah. Are there questions for Ujjwal? Yeah, please.
Ujjwal, very nice talk. So I don't have a specific question about this particular observation, but the time gap that you see in between the bursts. Is it same for all repeating FRBs, or like more or less same, or like
I think it's roughly at the same times as well. So a lot of hyperactive repeaters, I think almost all of the hyperactive repeaters where we have such a large sample that we can fit a waiting time distribution have bimodality, and it is very similar. So even the
bimodality is similar, but the time gap that I'm seeing here.
Oh, the time gap. Okay, again, for this FRB, for example, if you saw Laura's talk, she reported there was no time gap. So we are not sure if we had more bursts, this could get filled up. But the bimodality is seen in all of them. The time gap, may not necessarily be there.
In the things where there is nothing. But you can just find the difference between the peaks. Okay.
Sorry,
I can just find the difference between the peaks. Let's call that as a different time gap.
So that time gap must be similar. Yeah. So that is often, even the peaks are often at similar times, and the distributions are at similar time scales. So people often see, one distribution at very similar millisecond time scales, and then another distribution at a few second time scales. Often the peaks are at similar values. So that is something that is seen across a lot of
very
hyperactive repeaters.
And also, so you correct for the redshift, right? Not the redshift time, like 1 plus z.
In the waiting time distribution, I don't think I did a redshift correction here, because again, the assumption is that they are all coming from the same redshift. So I shouldn't need to. For the comparison, yes. Yeah. Although I don't know whether other people correct as well. I have a bit of a doubt there whether other waiting time distributions they correct for the redshift. So their comparisons might be a bit, for sure,
Sorry, questions?
Oh, hi, Ujjwal. Nice talk. Can you move to the last slide?
This one?
The very last, the summary thing.
Oh, okay, the summary.
Yeah, the last point where you're talking about temporal and frequency dependent evaluation. Are you going to push a theory that there is a plasma lens in front of it? That's why you see a sudden evaluation and the sudden magnification in a certain frequency area, the amplification, probably because of presence of plasma lens in front of it?
I could. I would like to have a look at all of the data first. So I have like 2 more epochs to analyze, and I have to collect all of the bursts and see. But that could be one of the theories, because we are seeing not just a trend, not just a simple trend. You're seeing that it moves back to low frequencies, then moves back again to higher frequencies. So it's kind of moving all over the place. It could be something like plasma lensing for all.
Yeah, because my comment comes from the talk of Ajay, and he was even showing the, I'll say, spectral evolution and also the burst rate as it going up and down, up and down.
Yeah.
Probably if you could model a plasma lens.
Yeah, it's possible, because as far as I remember, the host GM is quite large, and there is a PRS associated as well. So there is always a possibility that because there is a lot of plasma around the host, that there is, plasma lensing effects that are happening. Yeah, it's possible. But again, I would like to look at my data a bit more thoroughly first, because this data is just from a simple search that I've done till now. I just have searched for the bursts and I have them, but I have to look at the data to be very sure. Yeah.
Thank you.
This one.
Hi. Just one quick comment. The right peak in the weight time distribution, the position of it is just 1 over the rate of bursts that you see. So if you would see a higher rate, they would probably get closer and overlap.
I'm sorry, you're saying that the gap will get... No, I didn't get it.
Yeah, so the right peak reflects your rate of FRBs, the position of the right peak. So it would come closer if you saw a higher rate.
Yeah.
But my actual question was about, you said that the log normal is fitting the right peak better.
Yeah.
What kind of model comparison did you do there?
Oh, so I fit, if I remember correctly, a log normal, exponential. I think power law fits as well. I think a gamma distribution and a few others, I think. So I tried a lot of them, and the log normal was the best fit among all of those. So I basically I fit what would have been. So the waiting time distribution is exponential for a Poissonian distribution. So the exponential did not give me a good fit, which told me that this is not supposed to be Poissonian, and the log normal gave me a much better fit. So that's why I went for the log normal. Yeah, but I did like a comparison for a lot of different distributions. Yeah. Yeah.
We have time for one or two quick questions. Ujjwal, I'll have a question.
Sure. Yeah.
So are there any simultaneous observation by other observatories and or higher frequencies? Do they report anything?
Well, not that I know of, but again, the data set has been made public. So if somebody informs me, yeah, but I didn't do any simultaneous observations as of now. This is a purely GMRT based campaign. But if there is a chance that, for example, from either the old data set, for which the information is public, or the new data set for which the information will become public once I publish, if there are any simultaneous observations that I don't know of, I would be happy to check and see whether there are any simultaneous bursts at higher frequencies, for example. Yeah. 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 For the FRB itself, there are, of course, simultaneous observations. Yeah.
Yeah.
Yeah, sure. I'm sorry, I'm not sure whether okay, a pattern in all of the bands changing here, that's what I don't think so, because it has been a bit, so yeah, I know. Well, so okay, yeah, for 180916 there has been a clear pattern, but that is like an exception. Most have not shown a clear pattern in which frequencies they would emit at preferentially. It was 180916 which was emitting more in low frequencies than higher frequencies, so there was a clear chromatic evolution of its emission activity. But what we are seeing here is a bit random, so it does not match with anything that's happening there. There was, again, as Ajay mentioned in his talk, there was a chance that it was following a completely opposite trend. But from what I can see in my data, it's not holding up. So yeah, might just be random. Yeah, but 180916 is the only FRB. There's no other hyperactive repeating which shows a clear trend in chromatic trend in activity. Yeah.
Any other questions? Any polarimetric observations? Polarimetric analysis on the data?
Oh, so I do have some polarimetric data for this, but we will see how it goes. But the campaign kind of shifted its focus to studying the emission activity exclusively. So I don't have polarimetric data for what everybody would like for this very active epochs or the active epochs. So yeah, I won't be able to do it. But yeah, again, I think others are doing good polarimetric analysis with both GMRT and other telescope data. So yeah.
Thank you.
Yeah.
Yeah, please catch with all again. If you have some question comes up in your mind.